a circle a certain number of times, how far have you actually traveled? Think of it like this. So if you like a circle like this, all the length on the outside is your circumference. But if you spread it out so it's then a linear length, you get a distance. So each revolution that you're going around, you're actually traveling the distance of your circumference. So I'll write that out, that like one, this goes for like any wheel shaped thing. If you guys saw, I always think of like back in, like we ever had like in middle school, like field day outside, like the gym teacher pushes a little wheel on the stick and measures out like how big the field should be. What that machine does is each revolution, it's a certain distance that happens. So if you go like 5 revolutions, there's a certain number of feet that you have gone. Same thing with any other type of wheel. So 1 revolution for any wheel is equal to your circumference. Right. We're asking here in this problem, what happens or how far do we travel if we make 15 revolutions? Right? So that means 15 revolutions would be equal to our circumference 15 times, kind of spread out. Circumference, our formula yesterday, we had it 2 ways. We had it, I'll do this more at the top because there was a lot of questions on this. Circumference can be written as 2 pi r, or it can be pi times your diameter, right? Because 2 of your radii are actually the length of your diameter. That's why we can flip between the 2. So we're going to use this one. We're going to use pi times our diameter to find our circumference, because the hub of the wheel, we'd have to like split 15 in half and then add 5.5. It's probably easier if we just add all this up together to find our diameter. So the distance that we travel in 15 revolutions is equal to 15 times pi times our diameter. And our diameter we would get by adding 15, 5.5, and 5.5. So 5.5 plus 5.5 is 11. Add 11 to 15, you get 26. So our diameter is 26 inches. So that's our D value. So we can plug in 26 for D. So 15 times pi times 26. And this is in inches, so our final answer should be in inches as well. And then it just wants us to round to the nearest foot. So if you, on your calculator, you could type it in exactly like is, or you could use 3.14 instead of pi to get your answer. It's asking us to round to the nearest foot. We're in inches right now. So in inches, it's 1,225 inches. But we want that to be in feet. All right? So on big ideas, just be sure you're reading all the way through that. I think it's like the first or second one, you got to do a unit conversion. There are 12 inches in 1 foot, so the conversion would look like times, this is inches over feet. There are 12 inches in 1 foot, so we have to divide 1,225 by 12 to get our distance in feet. So 1,225 divided by 12, we're rounding to the nearest foot, so it'll be about 102 feet would be our answer. If a wheel just made 15 turns, we would travel 102 feet. So this can work for, like, if I was given, like, I make, how many revolutions do I make if I turn 15 times and my circumference is, say, I don't know, whatever distance? We could figure that out too. There's a homework problem like that where you're not solving for your circumference, but you're figuring out how many revolutions it'll take. And if you remember, one revolution is always equal to your circumference. That'll do you good. So maybe give this like a star or a highlight. Right. Kind of next example, now we're going to kind of get into the realm of measuring like perimeters of, you know, weird shaped things when we have kind of curves on them as well. So this time we're going to measure the distance around a track. Each end of the track has 180-degree arcs. So this end and this end both are 180 degrees, or half of a circle. The radius is 36.8 meters. We're asking how far does a runner travel to go around the track? Round your answer to the nearest tenth of a meter. So when you're running around a track, you have straightaways and you have where you're turning. Your straightaway distances, we have for, like, say this is where we're starting from. You run first a straightaway of 84.39. And once you make your turn, you have to run back 84.39 meters. So you could label that as well. So we know that's going to be part of our outside perimeter. We're going to have to take perimeter as all of our outside lengths summed together. So now we'll have to take 84.39 plus 84.39. So we have our straightaways covered, kind of what's here in red. Now we have to find the distance that we run on kind of the blue path, or blue paths. Where if we know this is half of a circle, this is a half of a circle, together, and we just kind of squish them together, we're actually running around one full circle, but we're just separating it by two long straightaways. So running the length around a full circle is like running around the circumference of your circle. So we have to add on our circumference. So we combine our 84.39 and add 84.39. That's 168.78. And then adding on our circumference, we know our radius. So we're going to use, this is our r here, we're going to use 2 pi r. So this is 2 times pi times, it says our radius was 36.8 feet, 36.8 meters. So again, if we do more simplifying, this will be 168.78. And here I'm going to multiply my 2 and my 36.8. So this will be plus 773.6 pi. And then we can type this in on your calculator as is, again using pi or using times 3.14. And you get out just about 400 meters. Which makes sense because that is the length of the distance of a track, 400 meters, all the way around. Which, I mean, you probably could say, like, don't assume that's just 400 just because it's a track. I mean, don't fall into that trap. Someone said we should just do that first hour. I said, who knows, it could be a smaller track. So whenever you're trying to find these kind of perimeter of oddly shaped things, think of like how many, like what is the actual circumference? How many full circles am I traveling? Or am I traveling a portion of a circle? And that kind of leads us into this next one. We have a path built around 4 congruent circular fields. The radius of each field is 100. What is the perimeter around the path? Round to the nearest hundredth. So when we're walking around this, we're walking around 4 kind of straightaway sections and 4 curved sections. We're walking around a curved section here, a curved section here, a curved section here, and a curved section here. So we have 4 quarters of a circle. So this all together will make one whole circle. All right, in full, we're walking around one circle. So our perimeter is going to have to use, we're going to use our circumference in there. Circumference of just one circle. We also walk around these 4 straightaways in red. And those 4 straightaways are just the distance from one, like our center point of the circle, to the center point of another circle. Or we're walking our radius, and then we're walking another radius. So we know this is 100 and 100. So now each one of these straightaways has to be 200 feet. So this is 200 feet. This is 200 feet. This is 200 feet. And this is 200 feet. So altogether, the straightaways, or our lengths in red, would sum to 800 feet. So it's going to be our circumference plus 800 feet. All right. Since we're given our radius for our circumference, we're going to use 2 pi r. So 2 times pi times r. Our r is 100. And then we have to add our 800 feet onto it, our straightaway section. So 2 times pi times 100, you could write that as 200 pi. Multiplying your 2 and 100. 200 pi plus 800. And then you could enter that on your calculator, again, using 3.14, or just using your pi symbol. And it wants us to round to the nearest 100 feet. So your actual answer you would get out is 1,428.32, but it wants the nearest 100 feet. So the nearest 100 would be 1,400. So 1,400 feet would be our nearest 100 feet. That's kind of the first chunk of your homework, doing those things. And again, a lot of it's just using circumference, find your straightaway lengths with your circle. If you're only to use, if you're going to walk walk a semicircle, that's your circumference divided by 2. If you were to just walk a quarter of a circle, that's your circumference divided by 4. And so on. You could keep divvying it up. All right, where are we on the back now? All right, you can flip to the back. We're gonna do something just this again, like I kind of told you all yesterday. This is a lot more, it's like plugging in numbers, doing math, and theorems and whatnot. So what we're gonna do is practicing converting degrees to radians and radians to degrees. So a radian is a unit of measure for angles, and we can convert from degree measure to radian measure and vice versa. So I found there's this nice little thing online that shows a good visualization of what a radian is. So a radian is made when the radius is wrapped around the circle, and then 1 radian is about 57.29 degrees. So this is what we mean when it's wrapped around. We take our length of our radius and kind of wrap it around the outside of our circle, and that's what makes a radian. So I think when we were doing degree measurements, I said on your calculator it could do two things. You can do degree measurement. Your calculator can be degree mode or it can be in radian mode. This is what radian mode is. Where instead of using like out of 360 degrees, it uses the length of your radius to find a length around the outside. So radian is just another unit of measure. So going back to the notes now, to convert from degrees to radians, we multiply our degree measure by pi divided by 180 degrees. To get from radians to degrees, we multiply by the reciprocal. So we multiply by 180 divided by pi. And whenever we write like degree mode, when you're writing in degrees, it could be any whole number, it can be a decimal. When we're writing in radians, it'll always be a fraction. You always want to express your answer as a fraction. You always have a pi in the numerator. What that'll look like is, so for example 4, say we want to convert 45 degrees to radians. I would say, well, I'm starting in degrees, 45 degrees. And to get to radians, I have to multiply by pi over 180. So when I do that, I would have 45 pi divided by 180 degrees. And we want to have our fractions as simplified as possible. So we're just going to go through and do some reducing steps. We're going to see what numbers go into each of these. I know that 45 and 180 are both divisible by 5. I don't know if it's the largest one, but I know they are both divisible by 5. So I can say, well, I can reduce to start by dividing 5 from both of these. So if I do that, this would be 9 pi. And this would be 180 divided by 5. Checking my math. Yeah, 36. All right, then I check again. Is there any number that goes into both 9 and 36? Well, I know 9 is divisible by 9, and I know 9 can go into 36 as well. So I can reduce, again, each of these by dividing out a 9. So this is pi over 4. That's how we would write something in radians. Pi over 4 is the same thing as 45 degrees. Now going the opposite way, where we're given radians to start and we want to convert to degrees, we multiply by the reciprocal. So we multiply by pi 180 over pi. There's a pi on the bottom, a pi on the bottom are going to pi on the top, pi on the bottom are going to cancel out. So we're just going to be left with a number. So you could do this two ways. You could cross simplify here, or we'll just do it how I did in the other problem. We'll simplify once we have all of our numbers in one spot. So take 3 pi times 180, or just 380 and stick the pi on. So that's 540 pi divided by 2 pi. Pi divided by pi is equal to 1. Because pi is a number. It goes away, simplifies to 1. 540 divided by 2 is 270. So this is 270 degrees. Again, they're both just units of measure. Think of it like centimeters and meters. They're both just units of measure. We use them for different things. They're part of the same family. We'll skip this 270 converting to radians because you would just do the opposite. You kind of work reverse. You take 270 times pi over 180. You get 3 pi over 2 as your answer. Maybe I put that in there to prove to us that it works both ways, but now it just seems redundant to do that. So. We'll convert 4 pi over 3 radians to degrees though. So 4 pi over 3 times, since we're going to degrees, I just think about moving to degrees, pi has to be on the bottom. So I take 180 times 4 pi, which will give us 720 pi, divided by 3 pi. So again, our pi's simplify to 1. So we just have to do 720 divided by 3, which is 240 degrees.